Welcome to Chapter 4. Chapter 4 is all about fractions. And so 4.1 is going to be an introduction to fractions. And so we'll go from there. In this introduction, we're going to talk about all the words related to fractions. We're going to talk about how to build equivalent fractions and look at how to turn fractions from improper fractions into mixed numbers. So those are some of the topics. So what is a fraction? A fraction is division waiting to happen. That's how I like to think about it. It's any number that can be put in the form a over b. And sometimes we write it a slash b. And all of these mean a divided by b. But often we can't do it, as in the case of 1/2. Let's say you have a pizza and you eat half the pizza, right? How we show this, because we had a whole that was then cut into two pieces, we have half of a pizza left, where this number down here represents the pieces in a whole, and then this top number here represents the pieces we actually have. So in the case of this pizza, I have one piece out of two remaining. Now, is it common to cut a pizza in half and then eat half of it? No, it's actually more common to cut it into multiple pieces. So if we, for instance, let's get rid of this and let's draw our pizza again, and let's put some new numbers in here. Let's try cutting it into fourths. So I'm looking at this example here, 3/4. So if I eat 3/4, and in this case, I'm looking at pieces we have eaten. So I'm saying I've eaten 3/4 of the pizza. I could also think of it as I have 3/4 of the pizza left, and maybe I ate one of the pieces. So the top number we call the numerator. And one way I like to think about the numerator is that it contains the word number. Well, sort of. It contains a lot of the letters that are in the word number. And it has its origin in the word number. And so the numerator is the number that we actually have. The denominator is the denomination. And when you think about the denomination in money, it's the size of the bill. And so in this case, it's the number of pieces in a whole is the denominator. The numerator is the number of pieces we have. So it's always numerator over denominator. And then here are some different examples. You could have this example here, D. So in this example, 4/8 of the squares are shaded. 1, 2, 3, 4. Well, what area of the whole shape has been shaded? Well, if there's 1, 2, 3, 4, 5, 6, 7, 8 pieces in a whole, and 4 of them are shaded, then that means half of all the pieces are shaded. And that's what this progression is trying to show us here, is that a half could be exactly 1/2, or the half could be 4/8, or it could be 3/6, or it could be 2/4, or it could be 1/2. And by that logic, it could be 5/10 or 6/12. Any fraction expression where the numerator is exactly half of the denominator will always be equivalent to 1/2. So let's quickly name the numerator and denominator for each one of these fractions. So for a, 3 is the numerator, and 4 is the denominator. For b, a over 5. Now, can we do a over 5? Is that a fraction that we can write? Sure, that's a fractional expression that I can write. I don't know what a is, but I can still write this as a fraction so that if I did know what a was, I could try to divide. And in fact, since a fraction is usually division waiting to happen that you often can't do, in this case it's totally fine to leave it as is. A is the numerator and 5 is the denominator. Now let's have a look at C. The number is 7. This might be a little counterintuitive, but all whole numbers can be written as fractions. They can all be written with the denominator of 1. One piece in a whole, hence the name whole number. And you have 7 pieces, and it takes 1 to make a whole. Oh, so you have 7 wholes. So if this were pizzas, I'd have 1, 2, 3, 4, 5, 6, 7 uncut pizzas, essentially. So I can always write a whole number as a fraction. And as we're going to see later, that can come in really handy. Because if 7 can be 7 over 1, then it can also be 14 over 2. Because 14 divided by 2 is 7. And 14 over 2 would reduce to 7 over 1. And so because they're the same, sometimes it could be helpful to write them in one form or another, as we'll see later. Okay, let's talk about the difference between a proper and an improper fraction. A proper fraction is one where the numerator is less than the denominator. So it's the typical fraction I think that a lot of us are used to, like 1/2, 3/4. But an improper fraction is one where the numerator is greater than the denominator. So that would be an example like 5/4. What is 5/4? Well, if I think about a shape and I split it into fourths, and I think about having 5 of these, then I have 1, 2, 3, 4. Oh, I need another fourth. I need 5. Oh, so what happens is when the numerator is greater than the denominator, it means I have more than one whole amount. Because if I had exactly 4 over 4, that would be one whole pizza. But since I have 5/4, what I have is 1, 2, 3, 4. I have a whole one. I have one whole one. And I have one piece of 4 of another. And so I actually have greater than 1. And so improper fractions are numbers that are greater than 1, and proper fractions are numbers that are less than 1, typically. And of course, as we'll see, once you add in negatives, it gets a little more complicated. Saying that, then you have to add in the idea of absolute value. We've seen that before, but for now, let's stay focused on the idea that improper fractions are greater than 1, proper fractions are less than 1. Now, one of the big takeaways from this section is writing equivalent fractions. The idea that you can build up a fraction and you can make it equivalent to some other fraction simply by multiplying the numerator and the denominator by the same value. And and it can be any value. Just like keeping an equation balanced, we have to do to one part what we do to the other. Keeping a fraction balanced, right? The way to do that is to multiply both sides. So for example, let's look at something simple like 1/2. 1/2 is the simplest way to write that, but it might not be the only way. So for instance, I can multiply 1/2 times something, top and bottom, and it can actually be anything as long as it's the same top and bottom, and I can build up an equivalent fraction. So let's try multiplying by 3, top and bottom. 1 times 3 is 3, and 2 times 3 is 6. Now the question is 3/6 the same as 1/2? And I think you'll find that if you have 6 marbles and 3 of them are red, then half of your marbles, right? This is 1 row out of 2. Half of your marbles are red. And so 3/6 is the same as 1/2. Sometimes it might be beneficial to write it as 1/2. Sometimes it might be beneficial to write it as 3/6. But we can build up any fraction to have an equivalent fraction. So for instance, 1/2. I could multiply top and bottom by 14. Then I would have 1 times 14 is 14. 2 times 14 is 28. But 14 over 28 is still the same as 1/2. Because if I have 14 out of every 28, I have half of whatever it is that I'm talking about accounted for. Now, let's look at some examples. We want to write equivalent fractions with, let's say, 3/4. So what I want to do is write an equivalent fraction with the denominator of 20. So I want to build up my fourths to have a denominator of 20. So what would I have to multiply 4 by to get 20? I'd have to multiply by 5. And whatever I do to the bottom of a fraction, I have to do to the top to keep them equivalent fractions. So 3 times 5 is 15. So 15/20 is the same as 3/4. Now, I don't just have to do this with numbers that I know, whole numbers like 5. I can do it with variables even. I can do it really with anything I want. As long as I do it top and bottom, I'll keep the fraction equivalent. So in this case, they say, we want you to write 3/4 as an equivalent fraction with a denominator of 12x. Okay, well, what would I have to multiply 4 by to get 12x? Well, I definitely have to multiply 4 times 3, and to get an x, one of them would have to have an x, and of course the 4 doesn't, so the 3 has to. So 4 times 3x, that would give me 12x. Whatever I do to one part of my fraction, I have to do to the other part of my fraction to keep it balanced. So I got to multiply the top. So 3 times 3 is 9x. So 9x over 12x is an equivalent fraction to 3/4, which is also an equivalent fraction then to 15/20. Now, if we can build up fractions with multiplication, then we can also reduce fractions with division. And I think some really relevant applications are thinking about how to simplify something. So is it simpler to say 3/6, or is it simpler to say 1/2? often we're going to prefer the simpler version, even if we're talking about 3/6, or let's say I'm talking about half a dozen eggs. Instead of saying 6 out of 12, I would still say half a dozen. And so let's look at an equivalent fraction, this example here, to take 10/12 and write it as an equivalent fraction with a denominator of 6. So instead of multiplying to build up, I'm going to divide to make smaller, to reduce. 12 divided by what gets me 6? Oh, 12 divided by 2. Whatever I do to one part, I have to do to the other part of my fraction to keep it balanced. 10 divided by 2 is 5. So 5/6 is an equivalent fraction to 10/12. They are the same, they represent the same amount. Now, an important point before we move on, now that we can build up and reduce fractions, is that the minus sign or the negative sign is something that we want to clear up here. So we can write the negative attributed to the numerator. We can write it attributed to the denominator, or we can write it attributed to the fraction and put it out in front. And so you could think of this as, well, what's -1 divided by 2? Well, what's a negative divided by a positive? Oh, a negative. So these are the same. How about a positive divided by a negative? A positive divided by a negative is a negative. So whatever the result is, it's going to be negative. Now, you can't divide 1 by 2, which is why we represent it with the fraction 1/2. But you know that whatever it is going to be negative. Now, what if both numerator and denominator are negative? Well, a negative divided by a negative is a positive. And so anytime that you have a negative top and bottom, your fraction will be positive. And anytime that only one, either the numerator or denominator, is negative, then the whole fraction will be negative. So let's write the following as equivalent fractions without a negative sign. So A, -1 divided by -5. A negative divided by a negative is a positive, and 1 divided by 5 we can't do, so I'll just leave it as a fraction, division waiting to happen. -A divided by -b. Well, I can't divide a by b. I don't know what it is, so I'm going to have to leave it as a fraction. But I know that a negative divided by a negative is going to get me a positive. So a divided by b as positives is a simpler way to write that. And C, -5 divided by -y. Again, I have no idea what 5 divided by y is, but I know a negative divided by a negative is a positive. And so 5 divided by y will be the same as -5 divided by -y. Now, that's the situation when we have a negative in the numerator and the denominator. What if we only have a negative sign in one or the other? What we want to do is typically we want to write that negative sign out in front of the fraction bar to represent the fact that the whole fraction is negative, because one negative divided by one positive is a negative. And of course, one positive divided by one negative is also a negative. So let's have a look at A. -1 divided by -4. -1 divided by +4. Negative divided by positive. I don't know what 1 divided by 4 is beyond writing 1/4, but a negative divided by a positive is negative. So -1/4 with the negative out in front on the same line as the fraction bar rather than attributed to the numerator is the better way to write this for most applications. B, -a divided by +b is -a over b. And C, positive 6 divided by negative y is negative 6 over y. Now, one of the reasons to write equivalent fractions is that so you can compare fractions and know which ones are smaller, which ones are greater. So look at these fractions, for instance. It might not be intuitively clear. Which is bigger, 3/4 or 2/3? Which is bigger, 5/8 or 5/6? Well, one way to know for sure which fractions are greater than which is to have the same denominator for all of them to get a common denominator. So, what is the smallest number? And I'm going to write all the denominators. These are the denominators. 8, 6, 4, 3. Well, any number that 8 will go into, 4 will go into, and any number that 6 will go into, 3 will go into. So what's the smallest number that 8 and 6 will go into? 6 won't go into 8. 8 times 2 is 16. 6 won't go into 16. 8 times 3 is 24. And 6 will go into 24, and so then 4 and 3 will also go into 24. So the smallest number, what we call the least common denominator, the common denominator of 24 is the smallest number that 8, 6, 4, and 3 all divide evenly into. So what I'm going to do is build up all of my fractions, 5/8, 5/6, 3/4, and 2/3. I'm going to build these up, multiplying so that I have a common denominator for all my fractions, so I can quickly compare numerators and tell which one is greatest. Because if the denominators are the same, then the greater numerator is the greater number. So I want to build up to 24 because that's the smallest number that all of my denominators go into. 8 times what gets me 24? 8 times 3, so I need to do that on top as well. 5 times 3 is 15. 6 times 4 is 24, so I need to do that on top as well. 5 fours is 20. 4 times 6 gets me 24, so I'll do that on top. There's 18. And 3 times 8 is 24, so 2 eighths is 16. Now I can quickly put them in order because the numerators can easily be compared now that the denominators are the same. So let's put them in order from least to greatest, smallest to largest. So the smallest numerator is the 15 24ths. So this one here is taken care of. And so that's going to be less than 16 24ths, which will be less than 18 24ths, which will be less than 20 24ths. So hopefully that is a good reason why we should learn to build equivalent fractions, because you can't necessarily tell by looking at it that 5/8 is smaller than 2/3, which is smaller than 3/4, which is smaller than 5/6. But once you put them in a common denominator form, you can. So now we're going to do the same thing, but with a negative number for each of these fractions. So it's going to challenge us a little bit when we rank them, but the process of getting a common denominator is going to be the same. So let's have a look here. So -1/4, -3/8, -5/6, and -5/8. Now, if we get a common denominator of 24, we're going to multiply each of these by something, and it's going to be different for each one, but it's going to be the same top and bottom within that fraction to get a denominator of 24. So 4 times 6 gets me 24. So that's going to be -6/24. 8 times 3 gets me 24. So that's going to be -9/24. 6 times 4 gets me 24. So that's going to be -20/24. And 8 times 3 gets me 24. So it's going to be -15/24. So now that all the values are negative, think about the number line between 0 and 1. 1/2 is here. 3/4 is here. 7/8 is there. But when we go in the negative direction, here's -1/2. Here's -3/4. And here's -7/8. So smaller fractions, when they're negative, are on the right. So they're actually bigger numbers. And that's going to be a little bit confusing for us because when they're negative, the bigger number is more negative. And so that's still true for fractions. So now that they're all in 24s, now we can arrange them from smallest to greatest, where the smallest number is actually -20/24, because -20 is a smaller number than, say, -15. Which is smaller than -9, which is smaller than -6. Okay, so one more skill we want to talk about is changing improper fractions to mixed numbers. A mixed number is a number that has both a whole part and a fraction part, so it's mixed. It has both parts. 11/4 is an improper fraction, and it's okay to write that in algebra. But what we can do is we can divide the 4 into 11, because 4 will go into 11. This is division that can happen, and we can get the whole part and the fractional part. So let's see, 4 goes into 11 twice, because 2 4s is 8, and that would leave a 3 remainder. And instead of writing a remainder of 3, what we're going to do is write the 3 over the 4. So we have 2 whole parts, and we have 3 out of 4 remaining. So plus 3 out of 4. So 2 3/4 is the mixed number way to write the improper fraction 11/4. So these are the same. Now, when would you use one or the other? Well, if we said, okay, how much pizza is left? You could say, and it's cut into fourths, let's just suppose. You could say there's 11 slices left, or you could say there's 2 3/4 pizzas left. Which one would make sense? That would depend on the context. One more improper fraction to mixed number problem. Here's one 10 thirds, 10 over 3, 10 divided by 3. Now, I can do this division. 3 goes into 10 3 whole times, because 3 threes is 9, with 1 left over. And so I'll write that as 1 out of 3 left over. Now, how can I check and see if I've done this correctly? What I can do then is I can multiply my whole number times the number of pieces in a whole, and then add that result to the number of pieces that I had left over. So 3, there's 3 1/3. So let's say this is pizzas. It's kind of hard to draw thirds very evenly, but we kind of get the idea. So I have 3 wholes. So 1, 2, 3, 1, 2, 3 pieces in each hole. 1, 2, 3. And then I have 1/3 as well. So there's my 3 wholes, and there's my 1/3. Now, how many pieces do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 pieces total. Where does that 10 come from? Well, I have 3 pieces. I have 3 holes, and I have 3 pieces in each hole. So 3 times 3 is 9. So that's 3 here, 3 here, 3 here. There's the 9. And then I can add that 9 to the 1 to get 10 thirds. So I can write this as 10 thirds, or I can write this as 3 1/3. And it kind of depends. If we're talking about, if we're talking about pizzas, it might make sense to do it both ways. But if we're talking about how many months it's been since you've seen a friend, 3 1/3 months makes a lot more sense than 10 thirds months. So let's review some of the key concepts here. Which term in the fraction 7/8 is the numerator? Remember, the numerator is the number on top. So 7 is the numerator. B, is the fraction 3/9 a proper fraction? The question is the numerator less than the denominator? The answer is yes. So then, yes, it is a proper fraction. C, what word do we use to describe fractions such as 1/5 and 4/20, which look different but have the same value? And that's because 4/5, if you divide 4 by 4, you get 1. And if you divide 20 by 4, you get 5. Oh, so 1/5 is the same as 4/20. So they are equivalent fractions. Equivalent fractions. D, why is 13/5 an improper fraction, but 3/5 is not an improper fraction? And it has to do with whether the numerator or the denominator is greater. So if the numerator is greater, then it's improper. And if the denominator is greater, then it is proper. So why? Well, because, so numerator and denominator. Denominator. There we go. So it's all about which one's greater. So when the numerator is less than the denominator, that is proper. And when the numerator is greater, when the top is greater, then that is improper. So hopefully that clears up a little bit about fractions. And if you have any questions, then please be in touch.